Welcome to the Open FPGA Stack training series. My name is Bark, and in this video I will show you how to use Open FPGA Stack Settings, or OFSS, to modify OFS designs. First, I will go over the theory of operation for Open FPGA Stack settings files, covering how the settings files work. Next, I will cover how OFS settings files are used, followed by a demonstration showing how to run the OFS build script with the OFS settings files. Finally, I will cover how to use IP preset files with OFSS. You can find additional resources, including detailed documentation on OFS settings files at the end of this training. To get the most out of this training, it is recommended that you understand the Discover portion of the OFS FPGA developer journey before continuing. This includes reviewing the OFS documentation, which can be found at ofs.github.io, particularly the Open FPGA Stack Overview and FPGA Developer Journey Guide. You can find OFS source repositories at github.com/OFS. You can find the release notes in these repositories as well. This training is associated with the customization step of your OFS FPGA developer journey. The OFSS flow allows you to quickly modify and customize IP within OFS FIM designs. The OFSS flow is a convenience tool for design modification, and you are not obligated to use any settings files during compilation if the source files are already configured as desired. Theory of operation. First, let's see what benefits the OFSS flow provides. With a standard manual modification flow, you as the user must understand underlying subsystems which often have intricate configurations with many settings and parameters. This takes time, and there is an increased chance that settings will be wrong or incompatible, which can introduce bugs and further delay your development cycle. When using OFS settings files, you can select from a subset of commonly used configurations, which the build script uses to automatically configure the subsystem parameters, settings, and even connections within the OFS design. This can significantly reduce your design time, as you can spend less time configuring subsystems and more time developing your workload. It also reduces the chance of errors and bugs in the design. An Open FPGA Stack Settings file is a list of design settings which you can use to specify certain design features. These settings take effect when you run the OFS build script. You can use them to build the default shells provided in the OFS source repository. You can use them to enable a subset of commonly performed IP and design customizations without needing to manually modify the IP or design, and in some cases, you can make OFSS files point to an IP preset file instead of listing specific IP settings. Using this feature allows you to make any IP modifications within the OFSS flow, even those not directly supported by OFSS. After you clone the OFS shell repository, you can run the build script while specifying a board target. The build script creates a work directory based on the source files, and then uses the default top-level OFS settings file to configure the design files and IP as defined in the top-level settings file. The default top-level settings file has the same name as the target board and includes all of the necessary settings to fully configure the design for the target board. The script then compiles this design into output binaries. You can specify OFSS files for specific IP to override the default IP configuration. In this scenario, a work directory is created and is then configured according to the settings file you specify, while the remaining IP is configured according to the default top-level OFSS file. This is then compiled. You may also manually modify an existing work directory. After making modifications, you can run the build script with the keep option to recompile the work directory in place. Now we will look at what you can do with OFS settings files in practice. The current OFS offering includes the Stratix 10 PCIe attach, the Agilex 7 PCIe attach, and the Agilex 7 SoC attach designs. Each of these designs has an individual GitHub repository. You can find detailed information on each of these designs in the OFS documentation, a link to which is provided at the end of this presentation, along with a link to the OFS source repositories. Of these designs, the Stratix 10 PCIe attach does not support OFSS. Looking at the Agilex 7 PCIe attach and SoC attach, you can use OFSS to modify these designs. For example, let's take a look at the Agilex 7 PCIe attach design. When you clone the Agilex 7 PCIe attach source files repository, it comes with all of the IP needed to build the shell. When you run the build script, it will use the default OFSS files to configure the IP based on the target board. For example, when targeting the N6001 board, the IP will be configured accordingly. You can also specify OFS settings to modify the default IP as desired. If you run the build script targeting a different board, it will use the default OFSS files for that board to configure the IP, such as the F-Series dev kit with the IP configured for F-tile instead of P and E-tile. Again, you can specify OFS settings to modify the default design as desired. Now we will learn how to use OFSS files. In the following example, we will look at how you can use OFSS files to build a specific Agilex 7 PCIe attached design targeting the N6001 F-Series P and E-tile device. Here is a simplified diagram of the N6001 FIM design. We will use this as a reference when exploring OFSS file usage. There are 5 types of OFS settings files. The OFS settings file contains board-specific information about the target board. The HSSI settings file configures the Ethernet subsystem. The PCIe settings file configures the PCIe subsystem and the PFVF MUX. The memory settings file configures the memory subsystem, and the IO-PLL settings file configures the IO-PLL frequency. OFS settings files are constructed with different sections separated by headers which define the settings for the design. The typical sections within an OFSS file are the IP section, which specifies what type of settings file the current file is, the settings section, which contains general IP and design settings, and sometimes other sections which are specific to the OFSS file type. Now we will look at examples of each settings file type. Note that these are just examples and that each OFSS file may support more settings than what is shown here. In an OFS settings file, the IP type is defined as OFS, and in the settings section, you can specify information like platform, family, FIM type, part number, and device ID. In an HSSI settings file, the IP type is defined as HSSI, and in the settings section, you can specify IP settings such as the number of Ethernet subsystem channels and their data rates. In a PCIe settings file, the IP type is defined as PCIe, and in the settings section, you only need to include the output name. Then you can define the number of physical functions and the settings for each physical function, including number of virtual functions and the address widths. The build script will use these settings to automatically configure both the PCIe subsystem IP and the PFVF MUX in the FIM. In the memory settings file, the IP type is defined as memory. The settings section includes the output name and the name of a preset file. As stated before, OFS settings files can point to an IP preset file instead of listing specific IP settings. In the case of the memory subsystem, the memory settings file points to an IP preset file by default. More information on using IP preset files will be covered later in this training. In the IO-PLL settings file, the IP type is defined as IO-PLL. The settings section includes the output name and instance name, and a section called pclock defines the frequency of the IO-PLL. Again, this is just an example construction of OFSS files. You may use any combination of settings files with your desired settings during your design process. Refer to the Shell Developer Guide for detailed information on OFS settings file usage and available settings. You can find links to the Shell Developer Guides at the end of this training. Let's take a closer look at the PCIe configuration. The default PCIe attached design has 5 physical functions in the PCIe subsystem. You can see the targets for each physical function connected to the PF/VF mux in the AFU shown in green. Now let's say you want to add a physical function to the design. To do this, you can simply add a physical function header named PF5 to the PCIe OFSS file. When you run the build script, it will modify the design to connect a new stub to PF5 on the PF/VF mux, and it will automatically update the PF/VF mux and ptile PCIe subsystem to support this change. If this change were made manually, you would have to update all of the settings in the IP for the new PF, including SRIOV, vendor revision and subsystem IDs, bar settings for MMIO, MSIX settings, and more. Incorrect settings could result in bugs and/or non-functional design. When you use the OFSS flow, on the other hand, all of these settings are updated for you automatically during the build flow. Once you are satisfied with the settings, save each settings file with a unique name. There is one more optional step during OFS settings file construction, which is the creation of a top-level OFSS file. A top-level settings file is defined by a default header followed by the paths to all of the individual settings files you wish to incorporate during the build flow. You can then save this as a single top-level OFSS file, which can be called when you run the build script. The OFS source repositories contain many pre-provided OFS settings files which you can leverage to make custom designs. For example, if you want to build an Agilex 7 PCIe attached design targeting the I-Series development kit with an 8x25 gigabit Ethernet interface, you can simply call the OFSS files for that specific configuration when you run the build script. Similarly, if you want to build the same design but with a 2x200 gigabit Ethernet interface, you can call the HSSI settings file that corresponds to the 2x200 configuration instead. In addition to pre-provided IP OFSS files, there are also pre-provided top-level OFSS files. These are configurations which you can use to quickly build different shell designs. These files are the default configurations that are used when no OFSS files are specified on the command line when running the build script. In this demonstration, I will show how you can use OFSS files when running the build script. Here is the usage of the OFS build top script. In the first example, I will run the build script without specifying any OFS settings files. In this scenario, the build script will automatically get the configuration based on the build target. In this case, it will default to using the N6001 OFSS file, since that is the target of this command. When the build script is run, all of the settings files defined in this top-level OFSS file will be implemented in the work directory and compiled. Here, I have already cloned the OFS Agilex 7 PCIe attached GitHub repository. When I change to the tools/OFSS config directory, we can see the provided top-level OFSS files. In the N6001 OFSS file, we can see all of the individual IP OFSS files that will be used when we run the build script targeting the N6001. Closing this file, I change back to the OFS root directory to run the build script. The build script is located within the OFS common directory tree. I then specify the target as N6001 and give a work directory name. Executing this command will run the build script. When the build script completes, you should see a message stating that it has completed and that timing has passed. In the OFS root directory, we now see the work directory and a log file for the build that was just completed. Opening the log file, we can see the full log of the build flow. Navigating down this file, we can see which settings files were used during the build and all of the settings within those files. As you can see, these settings were defined in the default N6001 OFSS file. In the second example, I will run the build script while specifying a single OFS settings file to change the Ethernet configuration to be 2 by 100 gigabits per second. In this scenario, the build script will use the HSSI OFSS file that I specify, then automatically get the default configuration for the remaining IP based on the build target. Notice that the HSSI settings file that I specify overrides the HSSI settings file defined in the default top-level N6001 OFSS file. When the build script is run, these settings will be implemented and compiled. From the OFS root directory, I change to the tools/OFSSconfig/HSSI directory. Here we can see the provided Ethernet OFSS files. Opening the HSSI 2x100 OFSS file, we can see the configuration for the Ethernet subsystem. Closing this file, I change back to the OFS root directory to run the build script. This time I use --OFSS, followed by the path to the settings file I want to use. In this case, that is the HSSI 2x100 OFSS file, which will override the default HSSI settings. I then specify the target as N6001 and give a work directory name. Executing this command will run the build script. When the build script completes, you should see a message stating that it has completed and that timing has passed. Let's take a look at the log file for the build that was just completed. Opening the log file and navigating down the file, we can see that the HSSI settings are the same as what was defined in the 2x100 OFSS file and that the other IP use the default settings. In the third example, I will run the build script while specifying multiple OFS settings files. This is done using a comma-separated list on the command line. In this example, I am changing the PCIe configuration to use only 2 PFs and changing the IOPLL frequency to 470 MHz. As before, the build script will use the settings that I specify and use the default configurations for the remaining IP. Again, the specified settings files will override the default settings files. When the build script is run, these settings will be implemented and compiled. Back in the OFS root directory of the cloned repository, I will run the build script. Again, I use --OFSS, this time followed by the paths to the settings files I want to use separated by commas. In this example, those are the PCIe host 2PF OFSS file and the IOPLL 470 MHz OFSS file. These will override the default PCIe and IOPLL settings. I then specify the target as N6001 and give a work directory name. Executing this command will run the build script. When the build script completes, you should see a message stating that it has completed and that timing has passed. Again, looking at the log file for this build, we can see that the PCIe and IOPLL settings reflect the 2PF PCIe and 470 MHz IOPLL. The benefit of using comma-separated OFSS files on the command line when running the build script is that compiling different combinations of configurations is cleaner, without creating top-level settings files for each configuration you want to test. This is especially useful when using a custom script to build multiple configurations. On the other hand, when building a specific configuration multiple times during development, it can be useful to have a combined OFSS file which you can use repeatedly. As a reminder, here is the previous example where multiple OFSS files were separated by commas on the command line. Now I will show you how to create a combined OFSS file that includes multiple individual settings files. In this example, I will use the same settings file from the previous example, but include them in a single combined OFSS file called N6001 2PF 470 MHz.OFSS. When building the design, we now only need to call the combined settings file that we created. The build script will behave the same as the previous example, with the PCIe and IOPLL configurations defined by the settings file we specify and the remaining IP configured according to the default settings files. Starting from the OFS root directory, I first navigate to the tools/OFSS config directory where I create a new combined settings file named n6001-2pf470MHz.ofss. In this file, I start with the default header followed by each settings file I want to include. In this case, the PCIe host 2pf OFSS file and the IOPLL 470MHz.ofss file. I save this file and go back to the root directory to run the build script. This time, after --OFSS, I only specify the combined settings file I just created, specify the build target, give a work directory name, then run the build script. Now I will explain how to use IP preset files with OFSS. As I mentioned previously, one benefit of OFS settings is that it provides a simpler IP configuration set, so you don't have to deal with the intricacies of IP configuration. That being said, if you do want to make finer modifications to the IP that is not supported by OFSS, you can still do so using IP presets. Here is the standard OFSS flow that we saw previously, where a settings file is used to modify IP and design settings. Now let's see how this flow changes if you want to create an IP preset to be used during your build. This flow describes how to use OFS settings to get to a starting point, then make further modifications to the IP. As before, you start with the OFS FIM source files, but this time you run only the setup portion of the build script with OFSS. The setup portion of the build script creates a work directory based on the source files, uses the settings file to modify the design files in the work directory, and stops there. At this point, you can open the IP in Quartus IP Parameter Editor. In the Parameter Editor GUI, you can make your desired changes. Then, you can create a presets file which contains all of the IP settings that you made in the GUI. You can then create a new OFS settings file which points to the presets file. Now you can run the full build script with the new settings file to incorporate the IP changes into the design. For detailed instructions on making modifications to the OFS designs, refer to the Shell Developer Guides. You can find links to the Shell Developer Guides at the end of this training video. To wrap things up, in this training we covered the OFSS theory of operation, including what OFS settings files are and what they do. Then we discussed settings file usage, including the different settings file types and how to construct them. Then we saw examples of how to run the build script using the settings files. And finally, we discussed how IP preset files can be used in conjunction with OFSS. The following resources are provided to aid your FPGA development journey. You can find OFS documentation at ofs.github.io. The Shell Developer Guides referenced in this training can be found there. You can find the OFS source repositories at github.com/OFS. Altera provides multiple avenues in which to learn about Altera products. The Altera YouTube channel contains many training videos like this one. On the Altera FPGA training website, you can access e-learning courses, labs, and demos. You can also enroll in a live, instructor-led course presented either in person at an office local to you or virtually over the web. If you need more assistance, Altera provides many self-help resources for you to access. You can view and post questions to the community forum, which is monitored by skilled Altera applications engineers. We are always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Thank you.